Would it not be nice if we were able to change our graphs here into dark mode rather than this one? It'll just be easier on the eyes and it will make them look a bit more professional rather than having dark mode for VS Code and then you suddenly have white background for a graph, which looks terrible. So in VS Code, it's very easy to do. All you need to do is add in one line here. And this isn't a feature of VS Code. This is a feature of Matplotlib PyPlot library here. So what it is that's a module, and the variable here, you can see we're using PLT, which refers to the PyPlot module over here. And here you can see when I hover over this, it's using the style module. So within the PyPlot module, there is a submodule called style. And that style module has a function. This function is called use. And you can see here, it's to specify styles. And there are some built-in styles that you can use. And one of them is called dark background, spelled exactly like this. So you need to type it in as shown here. There is no way around it. So do basically what I've done here, dark mode. And if I were to run this now, what you find is currently it's all white, horrible to look at, not very nice. So if I run this over here, and this has now finished, and you can see that my graphs are much better now. We suddenly have a dark background. And isn't this very nice? It ties in with our dark mode for VS Code. And this isn't a complete dark mode, but it's dark enough. I like it. And here you can see your graphs are much better on the eyes rather than what we had before. So remember, this simple line, you are using the style module within the PyPlot module, and then use the use function and simply type in dark background, and that will give you the end result here, and it works on anything within Matplotlib. So give it a go. You'll really like the dark mode within Matplotlib without having to do much work. It's pretty much configured for you. So yeah, very easy. Just remember dark_background and using the use function, using the style module within PyPlot, and that's all it takes. And you get the end results which look like this, much more pleasant than what we had before. Did you know you can create graphs like this in Matplotlib? So if you have a look at these graphs, they are very cool looking. If I scroll down, you can see these are the types of graphs you can create using Matplotlib in Python. So here you can see some more styles. You can see the scatter plot over here. So this one looks really nice. And over here, you've got a cool color map and some more styles. And here a bar chart that looks quite good. And then you've got some more that are really good. So if you have a look at these are in this MPC Cyberpunk. So this is the Cyberpunk game style graphs that you can do. So let's have a look at how you use them in VS Code. So here you can see that in VS Code, environment, I've got a Jupyter notebook, and here there are some built-in styles. So if we have a look at, for example, this style over here, this is built into Matplotlib, and you can see what that looks like. It looks like the example shown here. And you can see that the dark mode one over here. So if I activate that one, I'll comment this line out and make the other one available. So if we run this, and you can see this is the dark mode. But one other useful library is the MPL Cyberpunk. So Matplotlib Cyberpunk. And then when you install this one, so you can remember to add the % at the beginning to use pip install. So you can do that within your Jupyter notebook. You don't need to leave the environment. So after you've done this, so just run this over here, and you can see it's already installed for me. And once that's done, just import that library in. And then what you can do is you can uncomment this line out to use this style. So Cyberpunk, that's the exact wording that you need to use. So if I run this over here, and you can see that I have now got Cyberpunk style graph over here. And that's just by simply installing the Cyberpunk package over here and then using the plot style use. Remember, I explained these previously. Plot refers to this over here, and then you use the use function from the style module and just type in the Cyberpunk, and this will let you create Cyberpunk style graphs in Matplotlib. It's important that you install this, otherwise your code will not work. This package is needed for Cyberpunk graph styles to work. So with Cyberpunk, you can see here, you can get cool looking graphs like this. So these are really good on the eye, and they're very stylish. So to use them, all we had to do was install this Python library and package over here. And then using the plot style and the use function, we were able to use the Cyberpunk theme or style. So now you can add some fancy stuffs to your graph by simply adding in a few extra commands. And you might be wondering at the minute this isn't used, but you can modify the behavior of the theme by importing in Cyberpunk over here into your code. So as you can see here, what you can do is using the Cyberpunk module over here, you can add a few effects. So if we, for example, add a glow effect over here and see what that does. So if I run this over here, so here you can see that you must include these two parentheses at the end. So if you don't, did you do this? So if you just do that, then remember this isn't actually executing the function. So you must add the parentheses. And once you add them, you can see that this is the glow effect that you get. You can add other effects such as this one. So this one is make lines glow. So let's have a look at that one. And you can see what this does is this is different. It hasn't filled in the areas under the lines. So if we put the other one back in, which is add glow effect, you can see that it has added the area under the line with this glow over here. But if you were to use this effect over here, then you do not get the glows under your lines over here. But you can add it separately by using add underglow. So if you were to add this line over here and call this function, what this will do is add underglow, or you can turn this one off to get a combination of different effects. So you can see here, there's no glow, but there is an underglow here on the line. Like I said, if you want both effects, then you can add glow effects, and this will do both of them at the same time. And you can see the line is glowing too, as well as the underglow over here. So you can see how the effects behave. And then you can do other things such as you can use the add glow effect, but pass it gradient fill true. So let's see what that does. So you can see this actually creates the gradient effect to your graph, and it looks like this. So this looks quite good as well. And you can see how the gradient starts off dark and then lighter towards the bottom. So yeah, just by installing this library over here and then calling the different functions of it and passing the different parameters, you can get some really nice looking graphs in Matplotlib in Python. And these will be useful for your machine learning journey. How do you change this graph from side-by-side view to a vertical horizontal view in Matplotlib? So what I want to do is I want to place this graph at the top and this one at the bottom. So how do you do that? It's very easy, because in your code, when you create subplots, so this is how you create subplots. You use the plot module over here, and then you call the subplots function, and you give it a row and columns. So in this instance, you can see the way the graph has been set out over here is this is the first column, this is the second column. So it puts them side by side. But what you can do is you can tweak this and say that you actually want 2 rows and 1 column. So this grid layout over here, so if I were to run this, you can see what is as done is put the first plot over here and the second plot over here. Now, the weird part that you can see over here is that the heading is crushed. It's too tight together and you cannot really see the axis label and the title. So they are overlapping each other. So how do you solve this issue? Well, it's very easy. So what you can do is you can add this line over here to add spacing. So here, tight layout. And remember, this is using your PLT module over here. And all we are calling is this function, which is height layout. So by doing tight layout, and if I were to run this, you can see that now my graphs are not overlapping each other, and we can read the axes over here and they are much more organized. So how does this function actually work? What this function actually does is it will automatically figure out the text size, the graph location, and how big the graph is, and so on, and where do they end, where do they begin. It will work all that out, and then it will place the next graph further down from that point. So just by calling this function over here, tight layout, on the plot module, so plot module is there, just by calling that, you are essentially getting the function to do a lot of work for you. So you don't have to figure out how big of a spacing you need. Just use tight underscore layout and you will be sorted. So that's one of the advantages with Matplotlib. A lot of functionality that is very complex to code has actually been built in for you. And you end up with nice looking results like this with no issues. So remember, you can change, if you wanted a column layout, then what you can do is change that to 1 and say you wanted 2 columns, and then you'll end up with this layout over here as well. So it's very easy to change the layout. You just select the rows and the columns over here. So as you can see here in Matplotlib, we have 2 plots over here. So how do you actually have 3 plots? It's very easy. What you can do is you can change the parameters into the subplots function. So here we've got 1 row with 2 columns. So that means it is one row over here, and there are two columns or two graphs, one over here and the other one over here. So what you can do is you can change that to three, for example. So if I change that to 3 and run this again, you can see we now have 3 plots. So that's the second one, and then this is the third one. And in this fashion, you can continue to increase this to 4 and so on. So if you want actually 2 rows over here, so you can do it like this, 2 rows and 4 graphs. So what that will give you, so again, you can change that to this format over here, which is linear. So rather than having 2 columns, you actually are having 2 rows and 1 column, and you can exponentially increase this. So I can change it to 3 graphs, and you can see that it gets more and more complicated over here. Now, one thing that you can do is you can add spacing between your graphs. So here I could add like 0.9, and you can see that the spacing between the graph has changed over here, and that's just by using the figure variable and subplots adjust. So the figure variable comes from your figure variable here, which is obtained when you create the graph. So this is all on one figure. And what you can do is, as the number of graphs increases, so if I change that to 9 graphs over here and run this, you can see this has become too tight, and the size of this entire figure needs to change. So what we can do is, when we provided the parameters here, we can also actually specify the figure size. So over here, you can just add a comma and use the fig size function over here and pass it the parameters that you want here in centimeters. So this would actually change the canvas size over here. So if I run this again, and you can see now our canvas has gotten longer and longer, and that fits in all our graphs that we added, and you can make it even larger as you please. So here, if we change this to, for example, 20, you can see that it changed the width. So over here, we can change that to 5 just to see what the effects are. So here, there, you can see the width has gone smaller, but the length has continued to be very big. So over here, you could change this to 5, and you can see the detrimental effect that has on the output. So if we change that to 30 back in, and you can adjust it to your needs over here. Let's have a look at this very strange looking syntax in Matplotlib, and what does it actually do? So here, what you can see 2 graphs. So how did we get to these 2 graphs using this weird looking syntax? So this function Matplotlib over here, it takes in the parameters for how many rows, how many columns of graphs you want. And then you might be wondering, what in the world is this last parameter? What does it actually mean? And this is one of the strange things. If this means to select the last plot that you want the Matplotlib library to work on. So by calling this plot function, it needs to know where it needs to draw the line. So here we specified 1. Because we have 2 plots over here, we wanted to select this one and start drawing the data or plotting the data that we want it to draw on the graph. Now, the second line over here, you can see is pretty much the part over here. So this part is the same as this part over here. But this changes. This is 2 and this is 1. So what's happening is now selecting the second graph, which is over here, and going to use the plot function on that second graph, which is over here. So when you run the code, what happened is this data gets drawn on this graph because you provided this index, and this data gets drawn on here because you use the second index of the graph or the plot that you want to draw on. So this is the concept of subplots in Matplotlib. And you can easily change this. So you can see currently the second one goes up to 9 and the first one goes up to 6 because that's where, our data is. So we can swap it, and we can say, actually, this data, the one with the 6, draw it on our second graph over here. So we will use 2 over here, and this data here, draw it on our first. So now if I were to run this, what you'll see is it will swap the position of the graph. So if I run this, and you can now see 6 has become over here and 9 is over on this first graph over here, because we said draw the data, this data onto the first graph, and we said draw the data over here, which goes up to 6, onto the second plot. So this is the strange looking syntax explained. So just remember rows, columns, and index of the graph that you want to select. So there is some bizarre looking syntax that I want you to show you with Matplotlib. So this syntax over here, you can see it's pretty much, we are all familiar with these other parameters that we pass in. So in this instance, we're saying this is row number, we want 1 row of graphs, 2 columns on our plot, and select the second plot in our a graph that gets drawn over here. So you can see this is what the graphs look like. But did you know you can use a shorter syntax? So rather than having commas, what you can do is if I copy this line over here and paste it over here, and let's comment out that first line over there. And what you can do is you can basically remove the commas and have this sort of effect. So 1, 2, 2. So if you were to do that, then you will still get the same result over here. And like here, you can change this one over here. So if I copy and paste, you can then comment out this line over here. This line, we can just change and remove the commas like in so. And when we run this, you can see our graphs still get drawn. So what we can do is we can actually select. So for example, if we want to plot this data onto the first graph rather than the second graph, we can just simply replace this with a 1. So 1, 2, 1 and change this to 1, 2, 2. So that's just doing the same thing as I explained in my previous video, just selecting the second graph to draw this data. And on this one, it's the last digit over there is selecting the first graph to draw this data. So this one will draw and select this data onto the first graph, and this 2 will actually select the second graph and draw this data on the second graph. So if I were to run this over here, you can see that it has done so. So this data ends with 6 and it's drawn it on the first graph over here. This data is goes up to 9 and this gets drawn on the second graph. So this is the shorter syntax that you can use, and you may see it in other people's code. So I thought I would mention it, although it looks very strange, but it's just with commas removed. So you could add commas like this for clarity, but if you didn't want to add commas, then essentially you can just do this and this would still work. Don't ask me why they decided to have this strange looking syntax, but I guess it's shorter and quicker and it makes your life easier, but at least you now know what it does, and it's actually equivalent to the syntax over there. Matplotlib is very flexible, and if you're an object-oriented programmer, you might be uncomfortable with a lot of syntax that it has to offer. So what you can do is you can actually use it as an object-oriented objects in your code. So here, for example, you can see this syntax is very strange looking and you might be confused. What is it doing? I'm not even declaring any variables. I don't understand what this syntax is doing. So when you want to draw graphs on here, this syntax, although maybe some simple for others, but you who are with an object-oriented software engineer, programmer, wherever you want to call yourself, then you might be struggling with this idea. So what you can do is you can use this syntax. So here, this syntax may look very comfortable for some people, but for others, it may look very strange. But this is the object-oriented approach. So here, you're declaring and importing in this library, pyplot, and this is the alias we're using. And then using that alias, what we are doing here is we are declaring a variable, and that alias calls the figure function over here. This figure function returns a figure, okay? So it will give you a figure data type. From that figure data type, what you can do is you can then call the add subplot function. And this will give you a plot or an axis which you can draw on. So by using this, what you're doing is you want to create a subplot that is basically at position row 1, column 2, and then you want to select that first graph. So what this is doing is basically splitting your figure into a grid. So it's creating one row of graphs, 2 columns of graphs, and then selecting one. So here you can see down here, we've got 1 row. So that's 1 row of graph. And then we've got 2 columns or 2 graphs. And then we are selecting the first one. So if axis 1 for the plot 1 is using this variable. And then you can actually add your data points by using axis 1, which we selected here, and using the plot function over here. And this plot function will plot your data onto that graph. So when you run this, you get a graph that looks like this. And this is how you selected the other syntax over here. You can see there are no variables used at all. And you might go, what in the world are they doing? But if you're comfortable with the object-oriented approach, you can create objects, assign them to variables, and then using those variables, you can plot your graphs using this method. And this may make sense to most of you versus the syntax here, which doesn't use variables at all. So you've seen that we can create graphs like this in Matplotlib, which are this orientation. We can even, for example, change it to a different orientation. So we can change it. Actually, we want 2 rows, 1 column, and we can, for example, do this to 1 over here, and this will draw graphs on top of each other. But you can actually create pretty flexible and complex graphs that appear in this style. So if you look at that, that's top left graph over there, and then top right, and then bottom wide. So in order to draw plots like this, what you can do is you can use the Subplot2 grid function over here. And this syntax is very easy to understand. So if we have a look at the first top left one, and what I want you to understand between all this syntax over here is some common themes. So the first part you can see here, 2 for this function over here, and then there's another function here, Subplot2 grid, so it's the same function. And I want you to notice that this part is pretty much staying static each time we call the Subplot2 grid function. So what this does is it is creating a grid with 2 columns and 2 rows. Okay, so that's the first part. So if we go down here, you can see there are 2 rows, and 2 rows are shown here, and there are 2 columns. So what this does is the second part over here is selecting the first graph, so in position 0, 0, and then the second graph over here. In order to select the top right one, what you do is you want to select row 0 and column number 2, which is indexed at 1 because it's a 0 based index. But notice here for the wide graph, what you do is you, rather than selecting a particular graph, what you're going to do is you're going to select the entire row, and you're going to use the call span 2. Call span 2 is the one that will actually spread the graph over 2 top graphs that we have here, basically spread it over 2 columns. So what you're doing is you're selecting on row 1 the first column and then spreading that over 2 columns. And this will give you this layout. And then remember to use plot.height_layout here. And this will automatically make your graphs spread out quite nicely on the canvas that you have. And then you can have complex layouts like this versus simple layouts like this. So you can see this one looks much nicer versus graphs like this. If you end up drawing 3 graphs, then actually maybe this layout over here is much more suited for 3 graphs than drawing them side by side or on top of each other.